Hi everyone, my name is Ellie.
And I'm Rachel.
And we're here to talk to you about The Loop, a mixed-use multifamily design project. The Loop is an integral part of the sunblock system, which takes advantage of the existing city superblocks. In this sunblock neighborhood of Myers Elementary School, we work together with The Loop to convert excess solar energy in a thermal storage system located on site. Thermal energy is then used to distribute hot and chilled water to the surrounding single-family neighborhood. Many of you will recognize this as the duck curve. Solar panels installed on homes rarely have a way to store energy. So now in the middle of the day, all that excess energy is overloading our grid. And this energy is then unavailable in the evening when people need it most. This is especially true in the sunny Tucson, Arizona. This is why it is imperative that we turn to energy storage solutions and small grid systems like sunblock. The Loop itself was designed with a systems thinking mindset where we examined how feedback loops play a role in sustainability. On the left is the current unsustainable growth pattern of suburban sprawl, which leads to social isolation and climate change. In this mixed-use multifamily environment like the Loop, we can offer a new template for sustainable urban growth that strengthens communities and leads to sustainable living.
Our site is located in the Myers neighborhood, which has a household income that is 43% lower than the national average, compared to our city of Tucson, which is 26% lower. On the site is a vacant strip mall and almost entirely hardscape. This site best represents Tucson's predominant urban issues like routine flooding, poor walkability and public transportation, unused commercial buildings, and an overall disconnect with resources. With our systems thinking mindset, everything becomes part of an interconnected system. Because of this, we were able to address three huge concepts of gentrification, the energy crisis, and the climate crisis that we found equally important in this project. Addressing gentrification means asking yourself how the project can directly benefit the surrounding area. The Loop does this by connecting the Myers neighborhood to missing resources with an on-site daycare, library, shaded bus stop, and open office spaces noted in the site plan on the left. On the right, existing alleys have been remodeled into pedestrian walkways. The Loop also directly benefits its residents by operating as a co-op and providing them with stock upon moving in. This stock allows them to act as decision makers for the Loop and gives them ownership over it, even as renters. For market rate units, rent is based on a percentage of the surrounding median income. So rent can only increase if the people of Myers' income increases, not the other way around, aka gentrification.
For cities like Tucson, addressing the energy crisis looks like a reduced dependency on the existing energy infrastructure. Thanks to on-site solar, the Loop could be responsible for cooling the entire Myers neighborhood. The Loop also reduces its dependency on energy altogether through the integration of active and passive systems. Both the retrofit and the new building encourage natural ventilation with solar chimneys that help cool the new building on the left. These strategies work together with landscaping and active systems to cool and create microclimates. Because of failing infrastructure, it is important to be prepared for blackouts. Thanks to our commitment to designing the FEIS 2018 plus standards, during the hottest week of the year, the Loop will remain survivable for almost 3 days in the event of a blackout. Before the retrofit, the existing building would be unlivable by the end of the first day. We also include communication systems through our app and an on-site chiller plant run by on-site solar for emergencies such as prolonged blackouts.
Finally, we asked ourselves how to address the global climate crisis. Like many urban centers, Tucson is prone to cyclical and worsening flooding, with environments made up of so much hardscape that rainwater turns into rivers instead of soaking into the ground. Through the use of natural xeriscaping and bioswales, rainwater becomes a healthy part of the Loop system rather than something destructive. When we were asked to design a resilient building, what came to mind was one that could survive projections for climate change in the near future. To test this, we ran a weather file that resembled Tucson's climate projections for 2080 and found that our building will still be operating at current passive house standards. Another kind of global crisis emerged near the end of this competition. COVID has had people asking all kinds of questions about the safety and standards of the built environment, which is a great thing. We decided to evaluate our building in a pandemic situation without changing it, and found yet again that efficient buildings have a natural advantage and are the secret to preparing for an unsure future. Healthier buildings mean healthier inhabitants. Their air quality is better, access to outdoors is better, and even the close proximity to resources would be an advantage during a shelter-in-place scenario.
Understanding that no one component is enough to ensure a sustainable future, the loop operates as an interconnected system, aiming to break current unsustainable suburban growth cycles and introducing new patterns of energy production and use. Representing the first template for sustainable suburban growth through Sunblock's microgrid. Thank you guys so much for listening.
Thank you.
Okay, I think now Lydia and I will hop in. Lydia, I am going to assume you're ready. First of all, thank you all for being here and listening. Just let me know if you can't see or hear well. So our project is called Barrio Oeste, and we took second place in the mixed use multifamily housing division in the 2021 Solar Decathlon. This was our fabulous project team. So the site zoning allows for medium density residential and mixed use development with an incentive to build at high density in the spirit of urban growth. Our team has prioritized incorporating biophilic design principles, maximizing renewable energy resources, building for the future, and increasing equity in the community by sourcing local materials, labor, and city partners. The design is sensitive to Tucson's hot, dry climate, uses economy of scale to offset costs, and focuses on the user. So Barrio Oeste engages Barrio Sin Nombre, which is a forgotten neighborhood just to the west, by providing a community garden and guided access to the central plaza. The building form influences foot traffic from the Mercado and annex shopping centers to the north. Preservation of views celebrate the iconic Santa Catalina Mountains and Sentinel Peak. The rerouted Sunlink streetcar through the site and access to the Diamond bike loop encourage responsible travel options. Barrio is not only a place to call home, but also a gathering place meant to bring the Menlo Park community together right at the site where Tucson was born. Menlo Park has one of the lowest median household incomes in Pima County. Barrio Oeste is 50% affordable rental units and 50% market rate rental units. The rental units target young professionals, single parents, and multi-generational families looking for affordable housing options within Menlo Park and near downtown.
So under a high carbon emission scenario, Tucson's climate in 2080 will feel most like today's climate in Hermosillo, Mexico. A dynamic energy model with Hermosillo's climate information shows how Barrio Oeste meets all of the FIA's 2021 passive house requirements in 2080. Climate change exposes the vulnerability of the power grid. The power outage disaster simulation for Barrio demonstrates the temperature does not exceed 86 degrees Fahrenheit until the 5th day. That is the hottest week of the year in Tucson. Barrio utilizes a stucco and lime plaster as the external rain control layer, vapor retarders as air and vapor control layers, and wood fiber insulation as thermal control layer. Our team knew from the beginning of the design process that wood structure would be the most beneficial. By quantity, 59% of Barrio's structural envelope is made of wood-based products. Barrio's average EUI is 19.36 kilobtu's per square foot per year, significantly surpassing the mixed-use multifamily division target of the Sunblock competition of 79 kBtus per square foot per year. Barrio is part of the Sunblock District Energy Sharing System, which Sunblock uses on-site PV arrays that drive air-to-water heat pumps, which uses significantly less refrigerant than an air-to-air system. Heated or cooled water is stored in thermal storage tanks and transported throughout the neighborhood to help heat or cool other buildings. Longer facades face north and south, while vegetation in the central plaza development protects the east facade from direct sunlight. These heat avoidance strategies can reduce the energy consumption of buildings as much as 80%. Barrio's energy performance is calculated through a static and dynamic Eunbee model analysis. Each building is modeled separately to meet their own respective targets. The potential on-site renewable energy was calculated using PV watts calculator, and 75% of the roof area is used for PV panels. Each building is so efficient, we were able to meet its peak load with only 5 residential size air-to-water heat pumps. They make cool or warm water, which is stored in separate tanks, then when needed, come through the radiant floor in the residential units or through a hydronic air handler in the commercial portions of the project to provide comfortability of the building occupants. Proper material selection and assembly ensures the durability and performance of Barrio Oeste to the fullest. This project uses highly energy efficient HVAC systems, such as an ERV or DOAS, to provide advanced indoor air quality and radiant floor warm boards to properly condition the interior. Barrio Oeste also collects red and gray water to irrigate the entire landscape and recycle within the project. Our site promotes Tucson's sustainable and cost-effective options for travel by being adjacent to the Diamond Bike Loop that circumnavigates the greater area and rerouting the Sunlink electric streetcar that includes 24 stops within walking distance among hundreds of Tucson's most iconic features. People from across the city can enjoy Barrio's amenities and events with hassle-free parking, great community, live music, and so much more. Barrio is designed with many passive strategies, such as incorporating natural daylight and ventilation, as well as ensuring airtight assemblies with proper R values. Utilizing Tucson's 350 plus days of sunshine, renewable PV panels are spread across the roof to generate electricity and placed in thermal storage tanks that are used across the sunblock Menlo Park neighborhood. Surplus energy can be sold back to Tucson Electric Power if needed. Because of the structural open web truss system, Barrio provides space for ductwork and other utilities within the trusses instead of underneath. This is one of many inverted design choices that reduces equipment loads, general energy use, and inspires an overall improved living experience.
So the primary purpose of the Barrio app is to increase the occupant's life quality, and keeping a comfortable space makes this possible. Ventilation rates, humidification, and carbon dioxide levels are significant factors that impact indoor air quality. The app provides health and energy-related alerts aimed to improve the at-home experience of each user. Comfort strategies such as aromatherapy, biophilic design, natural lighting, and natural ventilation form a huge part of Barrio Oeste. Aromatherapy plants improve a person's well-being and help to de-stress. Biophilic design helps to also to improve the user's well-being, productivity, and creativity. Natural daylight improves mental health and physical health by also increasing productivity. Warm board is a structural radiant subfloor that maximizes performance. It has high conductivity due to the aluminum sheathing with lower water temperatures, which decreases energy use. The Ultra Air dehumidifier controls the humidity to reduce the dew point. Due to the use of radiant cooling, it is critical to keep the interior surfaces above the dew point temperature to avoid condensation. Through solar chimney design, the residents will be able to open up their windows to allow natural air to cool down the units. Thank you so much from Team Barrio.
All right, great work, Barrio team. Before I start, I just want to recognize my teammates that couldn't be here today. Eunbee Kang, Ashlyn Bonner, Matt Schur, and man himself, Jonathan Bean. Our project is CAMINO VERDE. It is a series of ADUs, accessory dwelling units, organized along a greenway in Tucson, Arizona. Three primary goals were considered when designing CAMINO VERDE. Our first goal was to design homes that reflect the desert building tradition in the Southwest, taking inspiration from buildings that were designed before the invention of air conditioning helps us think about dwelling using passive strategies for comfort. Our second goal was make a low carbon and zero energy building. It was vital that using low impact materials and rejecting fossil fuels for our energy needs. Our third goal was to deconcentrate poverty with affordable housing in the Menlo Park neighborhood by making quality homes for people who need it the most. And these three goals translated directly into the 9 project highlights. And each of these highlights guided us in achieving our design goals for the CAMINO VERDE. Just want to start by showing some perspective views of CAMINO VERDE from the neighborhood. When we first visited the Menlo Park neighborhood, we began to realize the immense potential and informal organic beauty that is common across Tucson and desert architecture. We drove up and down the alley system after a rare and brief snowstorm. We saw the incredible diversity of backyards that housed anything from sheds to gardens to the occasional personal junkyard. Snow in Tucson rarely sticks, and we were able to see the potential flood risk as we drove through the alleys and our vision for the project began. The alleys and backyards of the neighborhood offered the perfect opportunity for a new, informal, but connected alley system that could weave the neighborhood together through the rare but powerful events of rain in Tucson. By vegetating these alley systems, backyards could become a new prime real estate and offer a more well-rounded community. We also thought about how the simple cutting of slits into existing sidewalk retention areas could greatly increase water retention and local plant life on main streets of the neighborhood. By defining our site, we began to think about how the architecture of our now defined accessory dwelling units could come about. Our architecture is largely driven by empowering the people of the neighborhood to decide their own futures for both themselves and the neighborhood. We wanted to offer an architecture that could fit into each uniquely sized shape spaces of existing backyards in the area, while also offering answers to different target markets. We discovered that the biggest single category in the neighborhood is single parents, and we thought about ways our design could improve their lives. Our accessory dwelling units offered the perfect environment for multi-generational housing that help families help each other. Grandparents would be enabled to live in close proximity to their families while maintaining independence in their new ADUs. At the same time, the ADUs could offer small but efficient homes to anyone else looking for an evolving and new way to enjoy Tucson, or for owners looking for community-driven ways to additional income. As seen here, we developed 3 floor plans that each cater to differing needs, but are connected in that the larger Catalina and Santa Rita both stem from the smallest Rincon ADU. By allowing for the smallest Rincon unit to modularly grow in size over time through panelization, we were able to offer to their users the unique opportunity to start with the smallest unit and grow their home as their families grow. The majority of today's buildings are made of highly energy-intensive materials. The CAMINO VERDE ADUs utilize natural materials such as wood, clay plaster, invasive buffalo grass mixed with straw, and wood fiberboard to store carbon and offset emissions. Also, minimize material use from reduced floor and surface areas of these small accessory dwelling units have less embodied energy than traditional single-family homes. Lastly, to limit the use of energy-intensive concrete, the foundation is designed to lessen the amount of concrete. Our panelized assembly has potential for widespread use of low-carbon architecture in Tucson. To achieve our zero energy goals for this competition, we applied the sunblock energy loop concept with our high performance building assembly. Using the FIAS 2021 passive building targets, our group optimized and tested our building assemblies in Woofy to verify that we were meeting these targets. With a successful building envelope for Tucson's climate, we offset the energy using a solar roof ramada to support a photovoltaic system and provide a comfortable outdoor rooftop for ADU residents. On the neighborhood scale, the sunblock loop takes excess energy produced from the CAMINO VERDE ADUs through an air-to-water heat pump to transfer electric power into thermal energy. This energy is stored in water tanks that redistribute thermal energy during peak hours to reduce grid stress. Combining the sunblock loop with CAMINO VERDE ADUs is a sustainable and resilient alternative to grid-reliant homes. In an effort to reduce construction costs and increase affordability for lower income people, the ADUs will use panelized construction methods. The panels will be constructed off-site in a factory on the Barrio Oeste site that we just heard from, located in the Menlo Park neighborhood. This factory will be solar powered, reducing the carbon emissions from the prefabrication construction process. Prefabrication allows for the panels to be adjusted and customized to the ADU sizes and for the user's needs. And it also allows for workers and machines to be specialized in certain tasks, which helps increase production and reduce costs. Once the panels are on site, they will then be assembled together to form the ADUs. Due to the prefabrication process at the factory, the construction time will be greatly reduced, thus decreasing the total cost of putting the panels together. The buffalo grass insulation layer with the panels will help to incentivize a market for buffalo grass collection and get rid of the invasive plant from Tucson, which tends to perpetuate the spread of fires. Before concluding, let's take a closer look at the ADUs, the residents, and their liveliness along the Greenway.